Greetings to all of you. This is group 2 once again. We are going to do a presentation on determining and adapting appropriate teaching methods in our mathematics classrooms. So let's get into it by looking at a brief introduction to this. So as we all know, as facilitators and instructors, it is very important for you to be able to choose appropriate methods that will help your students produce a good result. So we are going to also see the adaptive methods help meet diverse learners' needs. So when we are able to bring these adaptive methods into our classrooms, it is going to address the diverse learners that we have in our classroom. So let's look at the teaching methods. Let's look at teaching methods. So they are basically a plan approaches that we use in delivering or giving out the content to our classrooms. Then we are saying that they influence how SHS students understand mathematical concepts. So when we are able to implement good teaching methods, they help students to grasp the concept that we are giving to them and be able to apply the knowledge they attain to solve problems. So let's look at the importance of selecting these methods. We have one proper method selection foster deep understanding and critical thinking. So as I have already talked about, we all know that when we are able to incorporate the methods that are suitable in our classrooms, it helps the students to understand the concepts. It also encourages the students and motivate them to be able to participate in the classrooms. And then we say that it also helps to reduce the gaps in the performances of our students. Let's now look at the factors that we can stand on to be able to take a good teaching method. Number one, we can look at the complexity of what you are going to instruct. And also you have to also see the learner's background and the previous knowledge that they have concerning to what you are going to be giving to them at that point in time. Then we say class size, time availability, and resources are also factors that influence the teaching methods that we are going to teach you. The class size also determine the time available to you and the resources that you are going to be using. Okay, so let's just look at the lecture method. So in the lecture method, you are going to have a description. That is where you are going to actually show the students the content you are going to give to them a step-by-step manner. Then we also introduce the topic. You have to introduce what you are going to teach. You have to introduce that topic to students. And let's see an example and the tools we can be able to use in help dispose this content to our students. We can see that as facilitators, we are going to explain the content to the students, and as we have here, we have calculus. We are going to use maybe chain rule, the quotient rule in explaining to SHS students. Then we
Taking the discussion method. So with the discussion method, learners ideas, they justify solution and analyze strategies together. Because it's a discussion method, they always come together and share ideas. Then the second one, it encourages critical thinking in SHS classroom. Yes, if the students are put in groups, they help to share ideas and it will help to improve classroom discussion. Examples and tools. Example, students discuss solving trigonometry identity. So when you put students into groups, they are able to share ideas and explain the identities of trigonometry for them to understand better. And the second one is the tools they use. So they think per share, board questions, group worksheets. So the students think alone, then they share with a partner to understand what the teacher teaches. Then we move to the advantage and disadvantage of the discussion method. So with that advantage one, it builds reasoning and communication skills. It is true because when you put them into group, it helps them to reason and also each communicate to each other to improve their skills in solving the question. Then when you move to the limitation, time intensive may require strong facilitation. So this one is one of the advantage of the discussion method because it takes time. Since you put them into groups for them to share ideas, it takes a lot of time. Please, I'll pass on to the next presenter to continue
Okay,
from there.
so I'll take over from cooperative learning. So cooperative learning is when students learn through collaborative groups. You group students who have you group good students with average students to work together to achieve what a common goal. So we are saying cooperative learning promotes teamwork and shared problem solving skills. An example in a math classroom is when you tell students to conduct a survey, right? When you tell students to conduct a survey, we have people who will conduct the survey, we have people who will record, we have people who will what calculate, and then we have those who present. So cooperative learning makes students work together and share what responsibilities. Can you please move on to the next slide? So we have strength and limitations of cooperative learning. What are some of the strengths of cooperative learning? We say it encourages interaction, cooperation, and peer support. As as you are learning together, you interact with each other so that you can get ideas from each and every one, right? And then it's also you need support from your peers. You might not know everything alone, so you need support from your friends. You need other friends' opinions in order to what carry out the work. And then it also has limitations. Some students may not dominate. Yes, it's in every group. It's in every group, right? When you are having a group work, you have students wouldn't want to participate in the group work. And because it's a group work, mostly it covers up for those students. And then we also have classroom and then we said classroom management is also needed. Please move on to the next slide. Now we move on to inquiry-based learning. Inquiry-based learning is a type of learning, right, where students are made to discover and explore things on their own. So as a teacher, you don't just give students the formulas, you ask them questions that make them what come about the formulas by themselves. It even happened to in my JHS, right, our math teacher didn't just go straight to give us the volume of a cylinder and all those things. He will ask you if you have a round surface, and then imagine I draw this, which parts would you call this part of the cylinder? Like, I don't know if you understand. Which part would this part be called? If this is the area and then this is the um, length, what do you think the volume would be? Like those kind of questions. Yes, when he did that, he made us come about with our own formula for the total surface area and all those things. So yeah, that's when inquiry-based learning is talking about, to make students explore things themselves rather than just giving them the formulas. So it encourages independent learning, and then um, um, it promotes critical thinking. Here we have an example here. Students use GeoGebra to explore transformations in geometry. Even in our university classrooms, the lecturer won't come and draw everything to you on the board. Sometimes they expect you to know the graphs in your head. The graph of course X, they'll be teaching and they'll be like, the graph of course X is like this, the graph of sine X is like this. So as a student, you need to go further to then explore it yourself. Please move on to the next one. We come to the strengths and limitations of what inquiry-based learning. Inquiry-based learning promotes deep understanding. Since students explore things themselves, when you explore things yourself, like honestly, it's even in general, when you explore things yourself, it sticks better than just going to class and then giving it to you. It also develops your reasoning, it encourages curiosity. You are able to we are curious to know what is happening next. Hey, so if this led to this, then how come this became this? Like those kind of things. Yes, it encourages curiosity, and then it improves your problem solving abilities too. So, what are some of the limitations? We are saying that weak students may struggle. Students who don't know anything about the topic, like they'll struggle when it comes to inquiry-based learning, since they are needed to explore themselves. And then it requires stronger guidance. And teachers need to help students who are very weak here. And then it is also time consuming, right? It's very time consuming because as a teacher, the curriculum might not permit you to have enough time to allow students to bring about their opinions. So yeah, sometimes you are being forced to just give them the formula instead of making them go and search for it themselves. Please move on.
Okay, we'll be picking from problem-based learning. And here, real-life mathematical problems are given to learners depending on context, and it helps them to appropriate knowledge to this context. It also encourages analytical thinking and application skills. So as they solve most questions, they become more alert of how to analyze issues pertaining the various settings. And also, let's look at this example. SHS student calculate compound interest for a savings project. And so that is a very good example. And learners go ahead to do work pertaining interest, how to calculate interest on savings. Now, let's look at the strength of this learning method. Links learning to real life, as I've already explained, improve analytical ability. Learners can put things together, disintegrate, and join things together, pieces. And then limitation here is time consuming as it requires skilled facilitation. The learners are to learn, master these skills. We move to differentiated instruction, and this is based on readiness, interest, and learning profile of each learner. If the person is audiovisual, the person is a visual learner, the person is an audio learner, all these things are factored into this part of this kind of instruction. And so it supports inclusion in essential mathematics classrooms set by Savina 2024. Let's look at this example. Tiered algebra tasks for both struggling and advanced learners. So we all know algebra has to do with diagrams, deals with algebraics. And so when learners are being addressed in their various needs, people who need to use graph, people who need to use only pen and paper, all these mediums are exposed to learners. So here we can use the tier worksheets, we can use visual aids, we can use adaptive apps, as you can have the GeoGebra and all that, and Desmos, all this helps learners in differentiated learning. Now let's look at the strengths and limitations. So the strength is support diverse learners, improve engagement. As I've already explained, learners are more engaged in these lessons, and everything is based on their interests and their learning profiles. Their limitation might be time-intensive planning and hard in large classes where people are many, and the facilitator is only one. It is not really effective in these classrooms. Now let's look at another one. We have technology-enhanced teaching. This is where we employ the modern technology in our lessons. So let's say use of ICT tools to supplement instruction. Now we can use projectors here. You can use calculators. You can use spreadsheets and all these things to help learners during lessons. It enhances conceptual visualization and interactive learning, where learners can critically and really imagine the situations and how well to conduct themselves in these situations. And so let's look at an example. So using GeoGebra, a model to solve geometric constructions and show almost all other things about constructions. And GeoGebra does not only all that, it can be used for other things too. So let's look at GeoGebra. There's more online quizzes, all these things helps in technology enhanced teaching. So let's look at the flipped classroom. So in the flipped classroom, students watch instructional materials before practice in class. And so you display your learning aids, your manipulates, and you make them deduce the topics themselves during these lessons. So SHS students watch calculus tutorial videos at home and apply in classroom situations. So we use video tutorials as I said, also we use Google Classrooms and all other things. Now let's look at the strength here. It offers personalized practice where the person watch the video one-on-one and also do personal deliberation and internalization of the concept learned, and also enhance student autonomy. Here the student can gain that independence in handling topics on their own. So what limits this method? It requires devices and internet access, and it will not be helpful to learners with economic issues or economic background. I mean, people who are barely uh, can barely afford to these devices. Now, let's look at our extra strength for all the method we just look at. The method is just to promote student autonomy. That is the independence I've already said. Encourage SHS learners to take ownership of learning themselves. Encourage real-world relevance. Connect maths lessons to practical lessons, problems like budgeting and surveys and all other things around them. Then the challenges might be limited ICT infrastructure and learning resources in some schools. As we all know, some schools don't even have ICT labs and all that. And then large classes and diverse abilities make method adaptability difficult when instructor is only one. Then, however, autonomy and relevance help improve engagement. Then, now last word, so practical tips for SS teachers. So combine methods. Don't use only one. You can sometimes use the lecture method, discussion plus inquiry, or problem solving based on the nature of the topic you want to teach your learners. Then reflect and adjust test based on student feedback. So don't be tuned to only one way of handling lessons. You can revise your methods and adjust it. If no discussion is not working best, then you can include something else, incorporate or any other thing else which works best for your learners. Now, we have a video which will talk about the universal design for learning, which includes all the methods that we just discussed. But for the sake of time, let's put a conclusion to this. Teaching methods must align with SHS objectives, student needs, and available resources, as well as being adaptive instruction. What we say promoting student autonomy and rewards relevance enriches SHS learners' achievement. So as we allow them to watch tutorials, practice, we have severally makes learning part and parcel of them, and taking them through real world problems and situations help them to achieve the confidence that we want them to achieve. Below our references to our work. Thank you.